In this video, we're going to use square roots to solve quadratic equations. First, let me remind you, what's a quadratic equation? Right? This slide here has 3 examples of quadratic equations. Right? What makes them quadratic is this x squared here. Right? An equation is quadratic if the highest exponent on the x is a 2. That's a quadratic equation. There's one other thing we need to just remember before we get into solving some quadratic equations. Right? We need to remind ourselves which one of these is always true. Right? And we talked about this before, but the answer is the second one. This is the one that's always true. Right? And just real quickly, let me remind you why. Right? Well, they're actually both going to be true if x is a positive number. Like let's say I use 3. Right? Square root of 3 squared, is that equal to 3? Right? This would be the square root of 9, which is 3. So that checks out, right? That's true. Right? And it would be true on this side as well, right? Square root of 3 squared, is that equal to the absolute value of 3? This would be the square root of 9, which is 3. The absolute value of 3 is 3. Right? So that's really easy to see that they're both true there. But the question is, what happens when we use a negative value? Let's say we use negative 3. Well, if I have the square root of negative 3 squared, is that equal to negative 3? This would be the square root of positive 9, and that's not equal to negative 3, right? That's positive 3 on the left and negative 3 on the right. So that's false. Okay? So this right here, the square root of x squared, you cannot say that's always equal to x. This one's always true. Let me show you. It works for negative 3. If I have the square root of negative 3 squared, is that equal to the absolute value of negative 3? Right? This would be the square root of 9, which is 3. The absolute value of negative 3 is 3. And so 3 is equal to 3. That's true. Okay, so this right here is really important. We're going to use this fact a lot. The square root of x squared is equal to the absolute value of x. That statement there is always true. Alright, so let's actually get into solving some of these quadratic equations. Okay, now the first thing you want to do is you want to isolate your x squared. Okay, and this one's relatively simple. Let's add 31 to both sides of our equation. So I would have 5x squared is equal to 45. Right? And next, to isolate x squared, I'm going to divide both sides by 5. Right? So now I have x squared is equal to 9. Okay? Now once you have your x squared isolated, here's what we can do. Right? We can take the square root of both sides. Alright, so now the square root of the 9 on the right, that's easy. That's just 3. But what about the left side? Square root of x squared. Well, remember on our previous slide, we said, what is this always, what can we say this is always equal to? Square root of x squared, that's equal to the absolute value of x. Right, so now we have this equation here. Absolute value of x equals 3. And I want you to think, what values for x would make this true? Right? And the answer is this could be true if x were equal to 3, or if x were equal to negative 3. So those right there are your 2 answers, right? And these are the numbers that would make our original equation true. Right? And you can check them. Right? If I put 3 here, 3 squared is 9 times 5 is 45. 45 take away 31 is 14. And negative 3 will also work as well. Let's look at a second example. Right, so again, first thing we need to do is isolate our x squared. So I'm going to subtract 5 from both sides first. Right, so now that gives me 30 is equal to x squared divided by 2. Right, next I'm going to multiply both sides by 2. Right, or you can think of it as multiplying by 2 over 1. Right, the left side would give me 60, and then on the right, I'm going to end up with x squared. Okay. All right, so now what do I do? Right? I have my x squared by itself, so again, I'm going to take the square root of both sides. Okay. So here's where you need to remember how to simplify your square roots. Right? In a previous video, we talked about how to simplify this. Right? We can use a factor tree. Let me actually go over to the side here and do this over here. So if I were to simplify the square root of 60, that would be, I can break this down as, how about 5 times 12? 12, we can break that down as 4 times 3. 4 is 2 times 2. So we can say that the square root of 60 is radical 2 times radical 2 times radical 3 times radical 5. And then by definition, the square root of 2 times the square root of 2 is 2. And then square root of 3 times square root of 5, that would be the square root of 15. So we can say that 2 radical 15 is equal to the square root of x squared, which is the absolute value of x. Okay, now let's think about this. If the absolute value of x is equal to 2 radical 15, what could x possibly be? What values could make this true? And there's two possible answers. X could either be positive 2 radical 15, or x could be negative 2 radical 15. Right? Because if I put both of those in here, this absolute value, it would make that true. So these are my two solutions. All right, we're going to look at one more. This one's a little bit more complicated. Okay. So this time, you notice I don't have an x squared. Instead, I have this whole quantity here, x minus 5 squared. But it's still going to kind of work the same way. Instead of isolating x squared, we're going to isolate this x minus 5 squared. Right? So that's pretty simple. I just need to divide both sides by 2. That's going to get me x minus 5 squared on the left, and I'm going to have negative 9 on the right. All right, and I'm going to use my square root again. So I'm going to square root the left side, and I'm going to square root the right hand side. All right, so the square root of negative 9, right? What's that? Right, let me work that off to the side. Right? Remember, in our previous video, we talked about this square root of negative 9. I could break that down as negative 1 times 9, right? And of course, we know square root of 9 is 3. Right? So let me rewrite this. We could say this is the square root of negative 1 times the square root of 9. The square root of negative 1, that's our imaginary number. That's I. The square root of 9 is 3. So this is 3i. All right, now this part's a little bit tricky, but the square root of x minus 5 squared, what will that be? That will be the absolute value of x minus 5. Okay, and so now we have this statement here. The absolute value of x minus 5 is equal to 3i. Right? And this actually works just like what we did in our previous example. Right? Think about this. Whatever's in here, if I take the absolute value of it, it would give me 3i. Right? So let's think about it. What could I possibly put in here? Right? What could possibly go inside right here? Right? It could either be 3i or it could be negative 3i. Right? So what we can say then is that x minus 5 could either be equal to 3i or x minus 5 could be equal to negative 3i. Those are the two cases. Okay? But we're not quite done yet. We still need to get x by itself. Right? So lastly, I'm just going to add 5 to both sides. And I end up, and I'm going to do that on both of these equations. And I get two answers. My first answer is this. 3i plus 5, I'm just going to rewrite that as 5 plus 3i. And then the other answer would be x is equal to 5 minus 3i. So these right here are my two solutions. These are the numbers that would make my original equation true. All right, here are two problems that I want you to try. Okay, and I've actually given you the answers here so you can check to see if you did it right. Okay, and then we'll practice some more of this in class.